Dear teacher, my name is Nina. Today, I would like to share with you a very important theory in educational psychology, cognitive load theory, and an interesting event, advertised reversal effect. And I also will share a specific example to explain how to apply advertised reversal effect in math classes. Firstly, let's start with cognitive load theory. Cognitive load theory was proposed by educational psychologist John Sweller in 1980s. Sweller's research showed that learning efficiencies decrease significantly when learning tasks exceed the processing capacities of working memory. This is mean working memory is limited. But what is working memory? Working memory refers to the abilities to organize and integrate information during learning. It's a core for processing information in our brain and is essential for learning efficiency. But as I mentioned earlier, working memory is limited. So how do we make the most of it? This brings us to different cognitive load in working memory. First, intrinsic load. Intrinsic load comes from the difficulty of what we are learning. For example, a new mathematical formula or grammar rules. It's a natural challenge. We cannot avoid this load, but we can manage it. And the second one, extraneous load. Extraneous load is a ended burden, which is something unnecessary that make learning more difficult, like confusing slide, confusing instructions in classes. This load is not helpful to learning and should be minimized. So if we want to make most of the working memory, we need to maximize intrinsic load and minimize extraneous load through appropriate management. But how to do that? Advertised reversal effects provide a good perspectives to organize learners' limited working memory. Advertised reversal effects shows that teaching methods for beginner may not be effective for more experienced learners. Probably this sentence is a little abstract. I will give you simple examples from daily lives to help you understand it. Let's talk about driving. For the beginner driver, it's necessary to remind him step by step what to do. Shift the gear, step on the gas, turn the steering wheel, turn on the turn signal, and so on. But for the professional driver, processing this information can be a burden. For them, driving like the muscle memory or programmed behavior, this do not require much instruction. More instructions might distract their attention. So what does the advertised reversal effect mean for us as teacher? This just means we need to adapt our teaching to follow our students' development. The same method won't work forever. What helps a novice can actually slow down an expert. Next, I will show you specific examples of applying advertised reversal effects on math classes. The learning task is students learn how to end fractions with different denominators. Let's start with novice learners. At this stage, students will still building this basic understanding, so we need to give clear and structured guidance. For example, when teaching the fraction addition like 1/2 plus 1/3, I will write it on the board and walk them through it step by step. First, convert the same denominator, 3 6 plus 2 6, and then n to get 5 6. I will also support this with visual aid, like circle mirror, to help students actually see what's happening. After that, they will practice similar structured problems to reinforce the rule. We call that mechanical exercise. This kind of an approach helps reduce intrinsic load by breaking the context into smaller and clear steps. But as the student get more experience and period knowledge, our approach needs to change. For expert learners, step-by-step instructions may no longer be helpful. In fact, they might even get in the way. So instead, I design open-ended task. For example, whether they are two fractions with different denominators and they're same as one, and explains your reasoning. This type of question encourages students to think flexibly and apply their knowledges in different ways. These shifts in strategies reflect expertise reversal effect. In conclusion, good teaching is not one size fits all. It must grow with the learner. When students have different proficiency levels, adjusting teaching strategies become important and necessary. Through proper instructional design, we can support both beginners and advanced learners, reducing unnecessary cognitive load and making learning more efficiency. That is the end of my presentation. Really appreciate your attention. Here is the references. Thank you.